Welcome back to our channel. The paper we are solving today is IGCSE Physics October-November 2023, and this is a paper number 21. Alright, let's start with the first question. Which is a vector quantity? Density? No. Mass? No. Pressure? No. Weight? Yes. Weight as force, force is a vector quantity. The graph shows the speed of a car traveling down a town. Which section shows the graph represents a period when the car is decelerating? We know that deceleration is change of velocity, decrease of velocity to be specific, and decrease is at part D. An object reaches terminal velocity after being dropped and falling through air. Alright. Which graph shows how its speed varies with time? We simply know that when something is dropped, it starts to accelerate, but it starts to accelerate with g. Then after some time, slowly, the acceleration decreases, and when it reaches terminal velocity, the acceleration is 0. So the speed should be constant. So answer should be C. Why not A? A is just a very sharp turn. It's not possible like this. Eventually what happens is slowly it is working under G. Then slowly acceleration starts to decrease because air resistance is increasing. So it should be like this. Answer is C. Question number 4. The table shows the mass and volume of three different liquids X, Y and Z. The liquids are placed in the same container. Alright. The liquids do not mix. Which liquid is at the top of the container and which is at the bottom? So we simply need to find density here. The one with the highest density will be at the bottom. So if you do 120 over 200, this is coming out to be 0.6 density. If you do 80 over 67, this is coming out to be 1.19 density, and 100 over 120, this is coming out to be 0.83. So now you can tell me which one is the most dense, which one should be at the bottom. Y has the highest density, so Y should be at the bottom. So from this only you got the answer. But the one with the lowest density should be at the top. Lowest density is X. So this is also supporting the answer. Answer is A. Now, which moving object has a resultant force onto it? Now, a lot of students will make the mistake here that constant speed acceleration should be 0 and then the force is 0. Constant speed acceleration is 0, force is 0. This is also force 0. Terminal velocity, we also know that net resultant force is 0. So which option is correct? Look at the option B carefully. An aircraft circling an airport at a constant speed. We know that whenever there is circular motion, there is a resultant force towards the center, even if the object is at constant speed. So answer should be B. Alright, do not make the mistake of thinking if constant speed is there, always net force will be 0. In most of the cases, yes, but in circular motion, even if the constant speed is there, the resultant force is towards the center of circle. Alright, forces are applied to four identical objects. Length of each arrow, what we need to do is that equilibrium should be there and each arrow should be in opposite direction to y-axis or x-axis, and it should be same in size. This cancels out this cancels out this. Answer should be B. Why not A? The arrows are oppositely different aligned. The direction is different. So this will more likely rotate the object, not an equilibrium. And here in option D, this arrow is larger, this is smaller, means the forces are unbalanced. Now, question 7 is a good question. A sphere X collides head-on with a second identical sphere which is stationary. The mass of each sphere is 0.15 kg. So let's say this is your X, 0.15 kg is the mass. This is your Y, 0.15 kg is the mass. But Y is initially stationary. And what is the speed of X? 2 meters per second. When they collide, sphere X is traveling at a velocity of 2 meters per second before the collision and produces an impulse of 0.21 Newton seconds on sphere Y. From this, you need to understand that the impulse on sphere Y is 0.21. What it means is that the change of momentum of sphere Y is 0.21. And we know that change of momentum is mv minus mu. And the initial velocity of sphere Y was already 0, right? So what is the mass of sphere Y? 0.15 into the velocity of sphere y is equals to 0.21. From here, you will get the velocity of sphere y, which will be nearly 1.4 meters per second. And some students will try to hurry this, rush this, and they will say, oh, I can see 1.4, so it should be out of C and D. This is the velocity of sphere y. You have to figure out for sphere x. So from this, it is obvious C and D is not the answers. Alright, but now how do we solve this? See, now sphere x, the mass is same 0.15 kg. You're trying to figure out its velocity now, and sphere y is 0.15 kg, and now it is moving with a velocity of 1.4 meters per second. So what we do? We apply momentum conservation. So 0.15 into 2 is equals to 0.15 into Vx plus 0.15 into 1.4. Now there was also a simpler method to do this, but most students do not understand that method. I'm using the lengthier method, but it's more on the simpler side. Alright, now let me just put in the values in the calculator. This will be 0.3, 0.1 into Vx plus, we already know this is 0.21. So 0.3 minus 0.21 is 0.09 is equals to 0.15 into Vx. So divided by 0.15, the answer is coming out to be 0.6 meter per second. So the velocity of x, indeed it is 0.6 meters per second. Now the direction, what about the direction? Will it be the same? Just think about it. If a ball is at rest and you are throwing another ball onto it in this direction, then both of them will move in the same direction, right? Until and unless this ball is extremely large in mass, then this ball will come and it will reflect back. But this is not the case. The mass is same. So they should be in the same direction. Answer is B. Alright. Now, question number 8. A cyclist travels down a hill from rest at point X. See, at rest and it is at some height, so it should have gravitational potential. Our answer should be out of A and B only. C and D is out. Without paddling, the cyclist applies his brakes and the cycle stops at point Y. So at point Y, your kinetic energy is zero. You do not have kinetic energy. Right? So midway, it should have some kinetic energy. Alright. So gravitational potential, then kinetic, then just think about it. When brakes are applied, heat generates, right? So answer should be A. What some students will make the mistake is that, oh, here we have GPA and at the bottommost point, kinetic energy is the highest. So they will directly pick the option gravitational potential, then kinetic. It is wrong. In this case, they are telling you it is coming at rest here. So it should be zero kinetic but more thermal. So answer is A. Now, question number 9. An object of mass m falls from a higher shelf to a lower shelf. Alright. How much gravitational potential energy does the object lose? So it is only covering this much height now. And this much height is h1 minus h2 only, right? So the answer should be mg h1 minus h2. You're coming from here to here. If you want to make it lengthier for you, you can also do it this way, that at this point you will have the gravitational potential energy mg into h1 because the height from ground is h1. And at this point, you will have gravitational potential energies mg into h2. Ultimately, you have to describe the loss. So mg h1 minus mg h2 it will be. So what is it? It is the same thing again, mg h1 minus h2. Answer is D. Question number 10. A pump does 460,000 joules of work to fill a tank. It takes 7 minutes. So this is a very simple question. Power is equals to work done over time. Time should be in seconds. So you will do 460 000 by 7 times 60 seconds. Alright. And your answer will come out to be A, which is 1.1 kilowatts. The water in swimming pool exerts pressure at the bottom of the pond. Which graph shows the relationship between pressure exerted by the water and depth of the water in the pool? Assume the density of water is constant. We know that pressure inside liquid is given by rho into G into change of height, right? Now they're telling you take this as constant and G is already a constant. So we can say pressure is directly proportional to the change of height. So it should be a straight proportion graph, linear relation, right? Answer should be C. Why can a gas be compressed easily into a smaller volume? All right. Why can a gas be compressed? See, if something can be compressed, it simply means already there is very high amount of space present between the molecules, right? The space is already high there, so particles are already far apart. Question number 13. A gas is contained in a cylinder by a movable piston. The gas is heated. Now, when you heat it, temperature increases, kinetic energy increases, then the forces increase as well. That it expands at constant pressure. So, whenever constant pressure is there, we know that temperature will be directly proportional to volume. How is the force of each collision on gas particle with the piston affected? Now see, if there is this much volume already, then frequency of collision will be some value x. But now if the volume has increased, but the number of particles are same. So frequency will decrease. Just imagine here you have 100 particles and now you are increasing the length of the piston. Here you also have 100 particles. So the frequency will decrease, but now since the particles have more energy, they will be exerting more force. So on a warm day, a carton of fresh milk is covered with a wet cloth. All right. Why does this help to reduce the temperature of the milk? See, the ultimate aim is that the temperature of milk should not increase. So now if this is your container, you're covering it with a wet cloth. So what this wet cloth is doing is that whatever heat is incident here, the wet cloth will absorb it. So we can say some of the water will evaporate from the cloth. So the remaining water becomes cooler. This is true. The water is a higher specific heat capacity. No relation. The water insulates the milk from the warm air around it. No. Water is always colder than the air around it. This does not make sense. No. So answer should be A. Now, question 15 is a very good question. And I want you to pay attention to this to understand this properly. Now, see. A chef heats some water in a pan on a hot plate. Alright. The temperature of water rises by 10 degrees Celsius in time T. So there is a wonderful chef. He's heating water and the water's temperature rises by 10 degrees Celsius in time t. Alright. She then puts the same volume of oil in an identical pan on the same hot plate. So now oil is entered here. Oil. The specific heat capacity of water is 2.5 that's of oil and water is 1.1 times denser than the oil. What is the temperature time for the temperature of the oil? So they're just asking you that we heated some water and it took 10 degree it took t time to increase the temperature by 10 degrees Celsius. Now we are using the same volume of oil in an identical pan on the same hot plate. So we're not changing anything. We are just changing the matter. We are changing oil, water to oil. Then they have given you some relations that the specific heat capacity is 2.5 times, density is 1.1 times. Now I'm a little bit confused which formula to apply here. But here specific heat capacity is mentioned. So let's write down the formula for specific heat capacity. Q is equals to mc delta T, where C is the specific heat capacity. Alright, so they have given us some values for specific heat capacity. Delta T we also know. Mass, however, is unknown. So does it mean mass we will take as same as the volume? No, this will be wrong because mass is equals to density into volume, right? We know that density is mass over volume. So mass is equals to density into volume. The volume is same, but the density is different. They've clearly written here. Water is 1.1 times denser than all. So you cannot take mass to be the same as volume. Alright, and now there is one more problem. We have to figure out time t, but in this relation there is no time. Delta T is temperature. So we know that power equals to energy over time. So energy can be written as power into time, right? So let me substitute it here. In place of energy, I will write power into time. In place of mass, I will write density into volume into C into delta T. Alright. Now we are finding the time taken for oil. So let's make T as the subject, density into volume into C into delta T by power. So this is our formula which we will be using here. Now let's write down some more relations. They're saying that specific heat capacity of water is 2.5 that's of oil. So we can say specific heat capacity of water is 2.5 that of oil. Cw is water, Co is specific heat capacity of oil. Density of water is 1.1 times that of oil. So density of water is 1.1 times that of density of oil. Alright, now let's clear some space here. Now, see, first of all, for water, the time it took is T. The density, I will write as density of water. The volume is same for both, so let's take it as V only. Specific heat capacity, I will denote it as Cw. Delta T is same for both, so you can write delta T or you can write 10, totally your choice. I'll take it as delta T only. And the power must be same for both. Now, the time for oil should be density of oil into volume into specific heat capacity of oil into delta T is same for both, and power supplied is also same. They're nowhere mentioning that I increase the heat, we decrease the heat, so power should be the same. Alright. Now just think about it. We will use the relations here. Time is equals to density of water is 1.1 times of density of oil. So 1.1 times density of oil. Volume is same and specific heat capacity of water is 2.5 times that of specific heat capacity of oil into delta T by pressure. Alright, now let's solve it here. 1.1 times 2.5 into density of oil into volume into specific heat capacity of oil into delta T by pressure. Right? Now, if you multiply these values, 2.5 times 1.1, this is coming out to be nearly 2.75. These two numbers, when you multiply them, it is coming out to be 2.75 into density of oil into volume into specific heat capacity of oil into delta T by pressure is the time taken. Alright, now I want you to pay attention to one important value here. Just look at this. See, this thing and this thing both are exactly the same. For oil, this is the value T naught for T naught, T of oil, and this we are also getting here. So in place of this, I can write T is equals to 2.75 into T naught, right? And we are finding out what is the time for the temperature of the oil to rise by 10 degrees Celsius. What is the time for temperature of oil to rise by 10 degrees Celsius? Temperature time for oil we have to figure out. So this will be T over 2.75. So when you divide 1 by 2.75, it comes out to be 0.36. So this is 0.36 into time. So the answer is A. Alright, it's a very good question. Now I will explain this again to you. See, what I did is heat is equals to mc delta T. In place of heat, I wrote power into time. In place of mass, I wrote density into volume. Then we made time as the subject. So density into volume into specific heat capacity into delta T by pressure, power. Alright. Now we have oil and we have water. So I wrote down the equation for water and we knew it took time T. So T is equals to density of water, volume is same, specific heat capacity of water into delta T is same for both. By power is same for both as well. Then we knew these relations that density of water is 1.1 times density of oil. So we wrote 1.1 into density of oil here, then volume, then specific heat capacity of water is 2.5 times density specific heat capacity of oil. So we wrote 2.5 times specific heat capacity of oil. into delta T divided by power. Alright. Now, when we multiplied these two numbers, 1.1 into 2.5, the answer came out to be 2.75. Then we arranged all these and we found out that for oil, the expression is exactly the same. For the time taken for oil, the expression is exactly the same. So, in place of density of oil into V into specific heat capacity of oil into delta T by power, I simply wrote time taken for oil. So time is coming out to be 2.75 into time taken for oil. In the question, they're asking you for time taken for oil. So rearrange this, time taken for oil is equal to T over 2.75. Answer is 0.36 T. Alright, I hope you understood this now. In case still you have a doubt, feel free to let me know in the comment section. Now, question number 16. The diagram shows the view of a room heated by a radiator. The arrowed line from X to Y is the path for the convection current in the air. Alright. We know that the heater is here. So this air going up must be the hotter air, right? So temperature at X should be higher. So A or B, one of our answers, one of our options from A or B will be correct. Air density, see this is colder air. Y is colder air. So the density should be higher at Y. Answer should be B. Alright. Now, two men P and Q stand close to a gap in a wall. Man P cannot see man Q, which is very obvious, but man P can hear the man Q speaking. See, the man Q must be speaking, so the waves must be going like this. And then, since it's a narrow gap, it must be getting diffracted. This is how man P can hear him. So, sound waves diffract a lot because their wavelength is similar to size in the width in the gap. This should be the answer. Light waves do not diffract. They're asking about hearing something. So, where does light come into play? Light waves again. Sound waves are of higher frequency, no logic. How is the person able to hear it? Him. Because sound waves diffract a lot, so P can hear him. Which quantities relating to wave on surface of water can be measured in meters? Amplitude, frequencies in hertz. So amplitude and wavelength should be the answer. Wave speed is meters per second. Alright. Now, question number 19. The diagram shows part of a ray diagram that demonstrates the formation of a virtual image Y of object X by a converging lens. Alright. Now see, this is the last case of lenses where a magnifying glass case is used, where virtual erect image is formed. They're simply asking you one ray of light from X is shown approaching the lens. Now, which row shows the direction as it leaves the lens? We simply know that it should go something like this. They have not mentioned the focal point here, but that is fine. What you can do is, if you want, you can just trace it like this as well. But that's not required. Currently, they're just asking you the direction. So the direction should be, it should be going like this, right? A ray of light is reflected by a plane mirror. Which row shows the angle of incidence? Oh, so we know that the angle should be taken from normal. So this is angle of incidence, this is reflection. So Q and R should be the answer. Option C. Question number 21. A thin converging lens is used to produce a real image of an object. Which statement about the real image is always correct? It is nearer to the lens than the object. No. It is in opposite direction to the lens of the object. This is correct. It is the same size. Not necessary. It is upright. No. Virtual is upright. But this is a real image. So answer should be B. A radio transmitter broadcasts at a frequency of this much. What is the wavelength of these radio waves? We know that V is equals to F into lambda. Now, since this is a radio wave, it will have the speed of 3 times 10 to the power 8. What is the frequency? 200 into 10 to the power 3 into lambda. So 3 times 10 to the power 8 by 2 times 10 to the power 5. When you solve this, your answer will come out to be 1.5 into 10 to the power 3, which is option number C. The element mercury exists as a solid, liquid and gas. Which row gives a possible set of values for speed of sound? Alright. So we know that speed of sound is the highest in solid, liquid and gas. So you just need to pick those numbers. In solid, frozen mercury is solid. So 2500 is the highest. Then liquid little bit less. Then vapor, the gas little bit less. Answer should be D. Which metal could be used for permanent magnet? Permanent magnet, we know that steel is used, and temporary electromagnet, iron is used. So answer should be D. Which statement describes the direction of an electric field at a point? Now, electric field is the direction of force on a positive charge. See, positive charge has the same direction as direction of electric current. What I try to say is that electric field has the same direction as direction of current. So it is from positive to negative. So it is a force on positive charge. Answer should be C. Question 26. A wire has a resistance of 8 ohms. A second wire of same material has twice the length but twice the cross sectional area as well. We know that resistance is directly proportional to length, inversely proportional to area. Now they're doing the length twice, but area they're also doubling. So ultimately this will cancel out. So resistance should be the same. B. A plastic rod is rubbed with a cloth. The rod becomes positively charged, means the rod is losing electrons. Because of the movement of charged particles, we know that electrons are the charged particles. So answer should be out of A and B. C and D is out. Now they're asking you the direction of movement. See, rod is losing electrons, so it should be from rod to the cloth. Answer is B. Question 29. An alternating current supply is connected to a diode and a resistor in series. Alright. The alternating current supply is this. This is a AC generator graph, alternating current. Which graph shows the potential difference V across a resistor varies with time t? Now see, just think about it. Alternating current supply is that current will keep on reversing its direction according to the frequency. So what we can do is we can assume that, let's say, first of all, the current goes to the left like this. Alright. So the direction of diode and the current is aligning. So it will allow the current to pass through. So it will go. Alright. So the first cycle is done, current is flowing. But in the second cycle, when the current reverses the direction, so it will start flowing like this. Now the direction of current is in the opposite direction to the diode. So in this case, it does not allow the current to pass through. So in the second cycle, current will not pass. In the third cycle, it will again go from the left. So it will allow it to pass. So we have to pick a graph where there is a value of current or voltage, then it goes to 0, then in the next cycle some value, then in the next cycle goes to 0. Answer looks like the answer is C. Voltage increasing, then after the next cycle goes to 0. Then voltage increasing, after the next cycle goes to 0. Alright. Now in case you are thinking why is this not A, why only C? See, there is a resistor applied here. Resistor will consume some voltage. It will consume some voltage as well as the diode will consume some voltage. So it cannot be constant. Answer should be C. 30. It's a good question. Those who remember this figure, they can directly pick that where to place. But in case you have not studied this, let me explain to you. And there are two ways to solve this. One is the shorter one and the second one is the more detailed one, more conceptual one. I'll give you both. Alright. So the diagram shows a circuit used to switch on a heater when the temperature drops. So now this is our main purpose. When the temperature drops, this switch must close. Means the voltage here should be high. When the temperature drops, this switch must close. So the voltage must be high here so that it will repel this. Alright. If the voltage must be high here, the voltage must be high here as well because Y is in parallel connection to this and we know that in parallel circuit voltage stays the same. So if voltage must be high here, voltage must be high here as well, right? Now let's look at this point. When temperature drops, resistance increases. These are, the semiconductors, these thermistors and LDRs are made up of semiconductors and this relation applies there that when temperature increases, resistance decreases. When temperature decreases, resistance increases. In the question, they have given us temperature decreases. So if temperature is decreasing, resistance must increase. Alright. Now, when you apply Ohm's law here, V is equals to IR, then R is increasing, so voltage must increase. But this is only when you have put the thermistor here. This will be applicable only when you have the thermistor here, right? Because what I'm saying is when the temperature decreases, resistance must increase. So resistance here must increase. Then you apply Ohm's law, V is equals to IR. If resistance is increasing, voltage should increase as well. which tells us that at Y thermistor should be there and at X fixed resistor should be there. So thermistor at Y, fixed resistor at B. So B should be the answer. Alright. Now, if you want a more detailed explanation for this, that we can also discuss. So now see. Let's say I'm putting the thermistor here, but I'll give you a better reasoning now. And we are putting a fixed resistor here. It will be a bit complicated, but just give it a try to understand. Otherwise, I've told you the simplest way already. Now, just think about it. If temperature is decreasing, the resistance is increasing. Then we can say overall resistance must increase. And if overall resistance is increasing, overall current in the circuit must decrease. Alright. Now you apply Ohm's law to fix resistor. You apply the Ohm's law here, then you can say V is equals to IR. And now in fixed resistor, the resistance is constant. In fixed resistor, the resistance is constant. The name is telling you fixed resistor, fixed resistance. So resistance is constant. So V is directly proportional to I here, right? And now you're saying current is decreasing. So if current is decreasing, V must also decrease here. So we have come to the conclusion that V must decrease here. Now just think about it. X and Y are in series, right? So if the voltage is decreasing here, voltage must decrease at Y. Sorry, must increase at Y. See, the battery is providing you 10 volts. Now it can be the same distribution 5 is to 5, or if one is decreasing, the other voltage must increase. So the voltage must increase at Y. That is why we put thermistor here. So this was a lengthier reasoning. I've given you both. Totally your choice which one you want to use. So from that also the answer is coming out to be B. Now, a current in solenoid produces a uniform magnetic field inside the solenoid. The magnetic field's direction is due east. Which changes will produce a stronger magnetic field? If you want a stronger magnetic field, you should use a stronger magnet or use a large amount of current. So smaller, incorrect. A and B is out. C and D, larger current, alright, and turn the solenoid through 190 degrees. See, if it mentioned 180, we could have done something, but then reverse the current and use a larger current. This should be the answer. When you reverse the current, keeping the other two variables constant, then the force will also change. So the answer should be D. Now, question 32. A metal rod PQ rests on two horizontal metal wires attached to a battery. The rod lies between poles of a magnet. When the switch is closed, the rod moves towards the right. So when this is closed, rod moves towards the right. Wait. Right. So it moves towards the right. Alright. What could be changed so that the rod moves to the left? Open the switch, it will not work. Reverse the battery terminals and exchange the poles of the magnet. If you change both of the variables, the direction will come out to be the same. You can use the Fleming's left-hand rule here, and you will notice if you change two things, the direction of the third one stays the same. Reverse the battery, but without exchanging. So you're only changing one quantity. This will change the other one as well. Alright, so answer should be C. This is more of a practical question. You should try using the Fleming's left-hand rule and just try to change as they're saying. You will find out that answer should be C. Now, a transformer in a computer is used to transform the mains voltage. So we have the V1 and we have the V2 here. The number of turns in the secondary coil. So this is N2 here. Which statement about the transformer is correct? First of all, it is decreasing the voltage. So it should be a step down transformer. C and D are out of the options. Then we have to figure out the number of turns on primary coil. So we know that N1 over N2 is equals to V1 over V2. You're figuring out the primary coil turns, so keep it as N1. N2 is 2000. V1 is 240 and V2 is 12. From this, you can clearly see that N1 is coming out to be 2000 times 240 by 12, which comes out to be 40,000 turns. So answer is B. Next question. In alpha particle scattering experiments, alpha particles are incident on thin paper metal foil. Which row describes the results from the experiment and the conclusion? Most of the alpha particles pass straight through the coil. This is correct. Most of the alpha particles pass straight through. This is correct. Very few alpha particles pass straight through. So option C and D are incorrect already. And what is the conclusion? See, if most particles are able to pass through, it means the atom is mainly empty space, right? So the answer should be A. Alpha particles, beta particles, and gamma rays are emitted by radioactive nuclei when they decay. Which emissions can be deflected by electric field? See, electric field contains positive, negative charge. So, which ones are charged out of these three? Alpha particle is positive, beta is negative, gamma is no charge. So, gamma will not face any force, but alpha and beta will. Answer is B. 36. It's one of the good questions. It is saying that radioactive X, radioactive isotope X, decays to form stable isotope Y. Alright. The graph shows how the mass of Y present in a sample varies with time. Which time interval gives the half-life of X? So they've given you a graph of Y, but they're asking you half-life of X. So it's one of the better questions. Now just try to understand it. There is your isotope X. It has initial mass m. When it starts to decay, means when it undergoes the first half life, it splits into two parts, m by 2 and m by 2, right? And it's mentioned here it decays to the stable isotope Y, means one of these parts is Y and the other must be the remaining part of X. Right? When something decays, half of it gets out and half is remaining. So m by 2 is remaining. Half m by 2 got decayed in the form of y. So it formed y because it is mentioned in the question, it forms y after decaying. Alright. Now just try to understand. Before the decay started, y did not even exist. Right? It is the question is saying x decays to form y. Now I am saying when the decay started, y did not even exist. So initially at t is equals to 0, y was 0. But when the half life happened m by 2, then y has some value, right? So we can clearly say that when y went from 0 to m by 2, that is the exactly the half life of x as well, because the first half life of x, which is m, is giving you m by 2, which is y. And how much time is it taking? It is only taking the first half life. So we can directly say from 0 to m by 2, the time taken is also the half life of x. Alright, and now I will explain this to you again. A lot of students end up being confused in this question. See, the question is telling us then when you have x, you have a mass m for it. It undergoes the first half life. It undergoes the first half life. So it converts into m by 2 and then the remaining m by 2 will also be there. Now the first m by 2, it decays to form stable isotope y. So now a stable isotope y is formed and this m by 2 must be the remaining part. Right? When something decays, half of it gets out in the form of decay, in the form of waste matter you can say, and m by 2, half of it remains. So I've written it like this. Now just think about it. Don't you think that before decay, mass of y was 0 and after the first half-life happened, mass of y is m by 2? Just think about it. Initially, before decay, y was not present at all. But then, when the first half life for m happened, the m by 2 got converted to y. This is what the statement is saying. It decays to form stable isotope y. Right? So, y is also equal to m by 2 for the first time. So, you can say when y is going from 0 to m by 2, this is also the half life of x, right? And when you check the graph now 0 to m by 2, what time is it taking? It is t equals to 2. You might have seen some teachers directly telling you that you just need to look at m by 2 and then you can directly put on the time 2. That gets you the answer, but it's not entirely a proper explanation. I could have done that, but I'm giving you the proper reasoning here. All right, just make sure to play the video again. I'm sure you will understand it. Now, another way to tackle this is that, see, when x decays, then y forms. So we can say when x is decreasing, y is increasing. So the graph of y is mentioned here, it's increasing, but the graph of x should be the opposite, right? The graph of x should be decreasing like this, right? So they are intersecting at which point? M by 2. And how much time is it? T2. This is also one way to try and get the answer. I've given you both the solutions. All right. M is converting to M by 2 at what time? It is converting at T2 time. So this is also one way you can solve this question. I've given you both the solutions. All right. Now, next question. Which particle is absorbed by a nucleus to cause nuclear fission? We know that neutron causes nuclear fission. So neutron is our answer. It is summer in the northern hemisphere of Earth in June. Which statement explains why? The Earth is closer to the Sun in June. This does not look like a logic a physics student will provide. So this is not correct. It's not that Earth moves towards the Sun, then away from the Sun. It's not like that. Earth revolves around the Sun. That is true. The Earth spins on its axis in the opposite direction to that in which it rotates around the Sun. Doesn't make sense. The moon is full in June. What does the moon have to do with the radiation from the sun? The north pole of the axis of the Earth's rotation is tilted towards the sun in June. Now, this is a correct statement. I'll tell you why. This is your Earth, and here you have the sun. So, the north pole is tilted at an angle like this. So, this region receives more sunlight during the day. This region receives more sunlight during the day. That is why option D is the correct one. No, no, no. Wait. We were not doing question 39. We were doing question 38. And D is the correct one here. 39 we will start now. Which statement about the sun is correct? The sun is a dwarf star, giant star, medium-sized star, medium-sized star. So it's not a dwarf star. It is also not a giant star. It is a medium sized star, true, consisting mostly of hydrogen and helium. This is true. Nuclear fusion reactions also take place, so hydrogen and helium are there. Now, question 40. The table lists some information about some stars. Which star will eventually explode as a supernova? Now, what most students will do is, oh, very weird names are given here. I think I've heard about Betelgeuse and I've heard about Sirius B. Sirius Black, right? You've heard about those. But it's not the point. The name of the stars are not required according to our syllabus, so do not get confused with it. What we know is that what is the stage before supernova? If I show you the photo here, look at the stage before supernova. It is red supergiant star, right? Now there is only one red supergiant, so the answer is B. That's it. All right. Now, going back to the most important questions from this paper, question 36, make sure to try it again. And then there was one more question for specific heat capacity. That was also a good question. Here it is. So make sure to rewatch this again if you do not understand it. Try to write it down on your own. That is only how you will understand it. It's a lengthy question. I've tried to make it simple for you. I could have used little bit ratios in maths and done it simpler in a less time, but it's not worth it because most of the students will not get it. So I've used exactly according to the ratios, taking common, and then we got the answer 0.360. All right. All right, so we are done with the paper. In case of any doubts in any of the questions, feel free to let me know in the comments section.